All right, today we're going to talk about the inverse of a square matrix. Okay, the matrices can be any dimensions, rows and columns. We are only going to find inverses that have to do with 2 by 2s. That's it. That's all we're going to work on. So the only time you guys are going to be asked to prove if something's an inverse, I'll show you how to do that. You're going to be asked to find the inverse. I'll show you how to do that. But the biggest inverse and matrix that we're going to use for this particular subject for inverses is just a 2 by 2. Okay? You guys are familiar when we talked about inverse notation. Remember we found inverses when we were solving? We switched x and y, and then we solved for the new y, and we wrote our inverse notation was like f -1 of x, and that denoted, that little -1 denoted our inverse. Well, the same applies if you're finding the inverse of a matrix. We name our matrices with big capital letters, A, B, C, so when you're finding the inverse, you need to tell me, hey, this is the inverse. And the way you do that is by that little a with the -1. So there's two ways that you can be asked these questions. You can be asked to prove that something is an inverse of something else, or that two things are inverses of each other, or you're going to find the inverse. So the first example we're going to do is we're going to prove that two matrices are inverses of each other. And the way that you do that is you multiply them together. You multiply them together, and when you multiply them together, their result is what's called the identity matrix. Thank you. This is the identity matrix. 1's on the major diagonal, 0's on the minor diagonal. Now, something that's very important, and you guys will see this in different stuff that you do, multiplying matrices is not the same as just multiplying numbers. When I say 3 times 2, I get 6, right? And when I say 2 times 3, I still get 6, correct? That's not the same when you multiply matrices together because of the way that we multiply. So A times B, the product of that, is not always the same as B times A. So when you're given two matrices, it's going to be a 2 by 2 square, and they say prove that they're inverses or show that they are, you have to multiply A times B, and then you have to multiply B times A. Both of those products have to be the identity matrix in order to prove that they are inverses of each other. So let's go ahead and do this. We'll do this together. We're going to do A. Here is A. It's a -1, -1, 2, 1. And we're multiplying it by B, which is 1, 1, -2, -1. Did I write everything correctly? Okay. This is a 2 by 2 times a 2 by 2, right? So the numbers in the middle are the same, correct? So we are going to create a what? A 2 by 2. All right, so let's go ahead and multiply here. We're going to take first row, first column. So I have -1 times 1, -1 times 1, plus 2 times 1. What's -1 times 1? -1 plus 2 gives me 1. Okay, so now I'm going to take first row, second column. So over here I have -1 times -2, right? Plus 2 times -1. So what's -1 times -2? 2, and then 2 minus 2 is 0. All right, so now we're going to go second row, first column, -1 times 1 plus 1 times 1. What's -1 times 1? And -1 plus 1 is? -1 plus 1 is 0. And then I'm going to take second row, you're fine, second column, -1 times -2 plus 1 times -1. What's -1 times -2? 2, and then 2 minus 1 is 1. When I multiplied, guys, A times B, did I get the identity matrix? Does it look like this? Yep. All right, so now we have to do the exact same thing, but we have to multiply B times A, because when you multiply matrices, it doesn't just become it's not just like a reciprocity kind of thing. So I have B, which is 1, 1, -2, -1. And then I have A, which is -1, -1, 2, and 1. Again, I have a 2 by 2 times a 2 by 2, so it's going to give me a 2 by 2. We don't have to go through all that again. You guys can do a little bit of this in your head if you want to. So I have first row and first column. So 1 times negative 1 is negative 1. Plus, what's negative 2 times negative 1? 2. So negative 1 plus 2 is 1. First row, second column. 1 times 2 is 2. Negative 2 times 1 is negative 2. What's 2 minus 2? 0. Good. All right, so now we're going to go second row, first column. 1 times negative 1 is negative 1. Negative 1 times negative 1 is positive 1. What's negative 1 times 1? Plus 1, I mean. Sorry, 0. Second row, excuse me, second column. 1 times 2 is 2. And negative 1 times positive 1 is negative 1. 2 minus 1 is 1. Did I create here the identity matrix? Yes. So what you guys just did is you proved that A and B are inverses of each other. All right? You may not be asked to prove on your test, but you will be asked to find the inverse. And then this is also a good way for you guys to check. All right, we'll check one of them here in a second. But in order to prove that a matrix is inverse of another, you have to multiply them together both forward and backwards, if you want to say it like that. A times B, B times A. Does that make sense? Okay. Moving along. All right. To find the inverse. To find the inverse. Here's the equation to find the inverse. This is super simple, I promise. All right, you are only going to be dealing, like I said, with a 2 by 2. So here is our just generic 2 by 2. You start with each entry has its own value. So A is top left, B is top right, C is bottom left, D is bottom right. You guys see that? We're going to talk about two different axes, the major and the minor. We're going to find something called the determinant. We're going to talk about that a little bit more tomorrow. But what you're going to do, the first thing you need to do is when you have your 2 by 2 set up, you're going to multiply A times D and subtract B times C or C times B, however you want to say it. But you take top left, bottom right, multiply it together, minus top right, bottom left. And you're going to get a value that we're going to put right here underneath this 1. And then you have to set up, because algebraically this works itself out, you have to set up the rest of your equation. What you're going to do is with the given matrix that you have, you're going to switch the places of the major axis. You're going to negate the signs of the minor. So look, if I had this, 1, -3, 6, -4. What two numbers make up the major axis? 1 and -4. So when I were to get this set up to find my inverse, what would I do with the places of 1 and -4? I'd switch them. I'd put -4 here and I'd put 1 here. This is my minor axis. What do I do with the signs of the minor axis? You negate them. You switch them. So -3 becomes positive. Positive 6 becomes negative. And then you just do the math behind it. It's a lot easier. I'm going to do 3 examples. It's a lot easier when we put numbers to it. But we got to find this value underneath here first. So let's look at this. Find the inverse. Okay, it says find the inverse. So that means there is one. You will get questions that say find the inverse. If there isn't one, state so. So the first thing I need to do is I need to find my value of A times D minus B times C. This is going to be very basic math, but there's going to be sign issues for some of you, so just pay attention to what you're doing. A times D is going to be 1 times -3, right? Minus what? -1 times 4. Lots of minus signs in here, so just simplify your multiplication first. What's 1 times -3? -3 minus, what's -1 times 4? -4. When I have minus and negative, it becomes, so my value is just 1. Okay, so let's get our inverse formula set up. Got to have my A to the -1. I have 1 over whatever this value is. So 1 over what? 1. And now I have to get my matrix set up. What happens with 1 and negative 3? They switch spots, so negative 3 goes here, 1 goes here. And then what happens with negative 1 and 4? They switch signs. This becomes 1, this becomes negative 4. What is the value of 1 over 1? 1. So I would do what with this 1? Distribute it. Does it do anything? No. So the inverse here is negative 3, negative 4, 1, 1. These two are inverses of each other. Now, how could I just make sure that I'm right? How could I prove to myself that, oh yeah, that works, that they're inverses of each other? You could multiply A times the inverse, and then your inverse times your original. And you should get that identity matrix. Now look at this. Does this visually, from A, and then the inverse of A, do they look like they're inverses of each other? They do, don't they? Yeah. I have positive 1 and 4 on the top row. And then I have negative 1 and negative 3 in the bottom row.
At this time, please submit the...
These look like they're inverses of each other. Some people will ask, well, can't you just look and tell it's inverses? Sometimes you can look and they resemble inverses of each other. But you need to mathematically prove, to find, and to prove if it says to. But sometimes you're going to see in the next couple examples, they don't look like they'd be inverses of each other. So let's go and do, we have 2 more examples and then we're done. Let's do this first one, A. All right, it says find the inverse if possible. That means it may not be possible. So first thing I'm going to do is I'm going to find my value of A times D minus B times C. What am I going to multiply together? 3 times 2 minus what? Negative 1 times negative 2. Good. So 3 times 2 is 6 minus negative 1 times negative 2 is positive 2. So my value here is what? 4. So I'm going to get my inverse formula set up. I have 1 over what? 4. And now I have to get the inside of my matrix for my formula set up. So what happens with 3 and 2? They switch spots, so 2 comes up here, 3 goes down here. And then what happens with negative 2 and negative 1? Not nothing. Their signs change. So negative 2 becomes positive, and negative 1 becomes positive. Now, what do you think I do, guys, with this 1/4? What do I do with the 1/4? I'm going to distribute it to each entry. And we like to simplify fractions. Do not leave your fractions as like 2 over 4. So when I multiply 1/4 times 2, I get 2 over 4. 1/4 times 2, I get 2 over 4. 1/4 times 1, I get 1 over 4. And 1/4 times 3, I get 3 over 4, correct? So we're going to simplify. So the inverse is 1/2, 1/2, 1/4, 3/4. Now, looking at your original and then your inverse, do those visually look like they're inverses of each other? No. But can you go back and prove, yes, that they are? Yes, you could multiply. We can do this real quick. We can multiply 3, negative 2, negative 1 and 2. And we'll multiply it by 1/2, 1/2, 1/4, 3/4. So think about it. We'll take first row, first column. What is 3 times 1/2? 3 over 2. And then what's negative 1 times 1/2? Minus 1/2. What's 3/2 minus 1/2?
3/2 what?
3/2 minus 1/2.
1.
1. You get 2 over 2, which is 1. Okay. So now I'm going to take first row, second column. 3 times 1/4 gives me 3 over 4. And then negative 1 times 3/4 is negative 3/4. What's 3/4 minus 3/4? 0. So now we'll take second row, first column. I have negative 2 times 1/2 gives me negative 1. Positive 2 times 1/2 gives me positive 1, so I get 0. And then I take second row, Second column, negative 2 times 3/4 is negative 6 over 4, right? No, 1/4, I'm sorry. Look the other way. Negative 2 times gives me negative 2/4, right? And then 2 times 3/4 gives me plus 6/4. What does that give me? 4 over 4, which is 1. Is that the identity matrix? Yes. Now, what would I do to continue to prove that these are inverses of each other? I'd then come over here and I would multiply 1/2, 1/2, 1/4, and 3/4
We don't have to do
times, nope, 3, negative 2, negative 1, and 2. And when I did, what would I get?
the same thing.
I'd get the identity matrix. I'd get 1, 0, 0, good. Now, Audrey just asked, we don't have to do that, right? You don't have to. But there's some of you in here that really like to make sure that you're correct and you like to check, and that's great. So if it says find the inverse and you just want to make sure that you got the inverse correct, you can just multiply them back together.
If possible, find the inverse. How would it not be possible?
Well, glad you asked, Audrey. Let's go through this one. All right?
I did that one. I got to see.
Okay, good. So let's find our A times D minus B times C value. I'm going to multiply here 3 times 2, right? Minus negative 6 times negative 1. Okay? 3 times 2 is minus negative 6 times negative 1 is 6. So I got a value of 0, right? You could stop right there and say not possible. And I'll show you why not. All right, let's get your matrix set up. What would 3 and 2 do? If I'm trying to find the inverse, what would 3 and 2 do? Switch spots, so 2 comes up here, 3 goes down here. What would negative 6 and negative 1 do? Switch signs, so I get 6 and 1. What value goes underneath right here in this fraction? 0. Can you have 1 over 0? No. Is that a value that you can distribute into the matrix? No. So when you get that value, it's called the determinant. When you get that, when you get the number underneath the 1 becomes a 0, then your answer here is either no inverse. I think on WebAssign they want you to say not possible. Impossible, maybe. They get real creative with their answers. But when this value underneath here becomes 0, there is not, an inverse does not exist for this matrix. Does that make sense? All right, so we're first going to multiply A times D minus B times C. And then switch. We're going to switch the places of the major, negate the signs of the minor, meaning if it's positive, they become negative. If it's negative, they become positive. And then whatever's on the outside we distribute and simplify.